This video, we're going to discuss about process identification system using a black box approach. So far, we have seen the process modeling can be determined based on chemistry and physics of the process. However, bear in mind, nature process is complex, and for complex processes, it requires development of rigorous theoretical models and large number of equations which is may not be practical because the mathematics contain a significant number of process variable and unknown parameters such as chemical and physical properties. Complex processes are way too complicated to model using physical principles. This is because it involves material and energy balances, flow dynamic of liquid in the piping, physical properties which is often unknown, and thermodynamic principle and properties of materials. An alternative approach to develop an empirical model directly from experiment is called as a black box approach. Empirical model are sometimes referred as a black box model because the process being modeled. Here, the input and the output variable are known, but the inner working are not. This activity to identify the process model is called process or system identification. In general, empirical dynamic model are simpler than theoretical model, whereby this theoretical model is basically correspond to the extensive mathematical derivation. And this empirical dynamic model are offering several advantages and that can be solved in real time. In simulation, the process model M is known and we wish to generate the response yt for a specified input ut and a specified disturbance dt. If M is a linear dynamic model and ut and dt are expressed analytically, yt can be derived using the Laplace transform. But if N is a nonlinear dynamic model, yt can be obtained by numerical integration after ut and dt are specified. In process identification or in system identification of model M is determined from data ut, yt, and dt if d can be measured. Only if d can be measured. Empirical dynamic model typically are low-order differential equation or transfer function models. Example, first or second order model, perhaps with a time delay, with unspecified model parameter to be determined from experimental data. But of course, there are certain limitations of a black box approach. Again, black box approach is basically system identification using empirical data. One of the limitation is basically because of the step response. Even though step response is easiest to use, but it may upset the plant manager. This is due to the size of input change and the step response change from minimum to maximum. That is what we call as a step input. Other method compared to the step response is impulse, such as dye injection or tracer, random input, which is pseudo-random binary sequences, sinusoidal. This is actually a theoretical approach. We can also use frequency response. This is a modest usage, including pulse testing, or this is one of the among the popular method, what we call as the online method. This is conducted under uh, feedback control. Again, for black box approach, the limitation is only good for fixed operating condition, but require operating plan, which is the actual data. So we cannot use simulated data. We have to use actual data. And we have to, another limitation is need to minimize disturbance during a plant test. So somehow we have to try to minimize as much disturbance as possible during the plant test. The ultimate objective of empirical model or system identification is to get the model of the system. Often we can have first order model which represent a process control. This particular illustration illustrate and show a common system identification which represent a process control. This plot is the output response of a process to a step change in input is sometimes referred to as process reaction curve. So this is also called as the process reaction curve. There are two parameters that are very important in process reaction curve. The first one is what we call as the time constant, which is tau, and another one is what we call as a gain, which is what we call as the k. This is because we know that this is first order system, and in terms of transfer function, first order system normally represent by k over tau s plus 1. And k is basically the gain for the process, or we call it as the process gain, and tau is actually the time constant. That's all for now. Thank you.